Ciuksys. Today I'll present our comparative study on event extraction for the Lithuanian language using two approaches. One is new autonomous model trained on the annotated data, which was generated using large language models. And the other approach is few-shot prompting of large language models without any fine-tuning, just with different prompting techniques. Both approaches, they are previously researched and presented by me. Okay, so first of all, I would like to introduce you what is an event and what is event extraction. An event is the thing that happens or takes place. In our research, we chose a sentence-based model for event definition, where as an event could be identified any sentence in the text. Here you can see an example sentence, which is of contact meet event type. The main word in the sentence, which describes event, the best is word visited. And for resource-rich languages like English, event extraction is widely studied. There are many different goal corpus created and different models and approaches as well. But for languages like Lithuanian and other under-resourced languages, this topic is often not researched at all. And the main point of this research is to analyze and present what are the best possibilities for automatic event extraction in under-resourced Lithuanian and explore how two event extraction approaches address data scarcity. And the best performing models for the source-rich languages are specifically for this event extraction task trained advanced machine learning models. And in order to train such a model, you need large-scale manually annotated data set. And to create extensive and detailed goal corpus is very time-consuming and resource-rich. For Lithuanian language, there are no such data sets. So for the first approach, we research the possibility to use large language models here in this research, OpenAI GPT and Google Gemini, and use that data for new machine learning model training. And as for the second approach, we analyze the possibility of large language models to classify a sentence as events with a few-shot prompting. Both approaches shares the same common ground, which allows compare them directly. In the first and in the second approach, the same two events types were chosen. Furthermore, the same initially created goal corpus was used of annotated events in Lithuanian. And both approaches performed automatic event extraction on the same text, of which annotation results were compared with expert manual annotations. And for the same comparative metrics were got as the results. And in order to perform everything in automated manner, new event GPT application was crafted for this task, which was connected to OpenAI and Google Gemini through the APIs interfaces. As you can see, here's an example of this newly crafted application, and here you can see Lithuanian text. In that text was annotated sentences like this. And the first approach, the core idea of this approach is to generate thousands of labeled Lithuanian sentences with bad and good examples of two event types. And they were generated two different data sets. One was small, consisting of 1,290 sentences, and the other one much larger, which totaled of 54,000 sentences. For the simplicity, maximum entropy model were chosen, and using both data sets, we were generated two, not trained two different autonomous models, which could perform automatic event extraction on Lithuanian text. The main advantage of this approach, but we don't need resource-rich manual annotations, and synthetic data generation could be scalable to thousands of examples with potentially diverse morphological coverage. And the main disadvantage but data set created in which way can lack of real-world examples and real-world diversity, because large language models generated text often generate hallucination and some patterns which are not reflective of real world. And in order to mitigate this disadvantage, we need to carefully we need to carefully craft prompts in order to avoid repeating sentences and to get as much diversity as possible. And the results, and after performing the evaluation of this model, it's clear that model trained on, as you can see, on larger data sets should show the better results because of likely higher diversity level, which allowed machine learning model to classify sentence to events better. And on the larger data set, all four metrics improved. However, precision remained moderate on both data sets. And let's move to the second approach. The core idea of the second approach is to prompt model with a minimal set of examples without any previous additional fine-tuning of the model itself, and hoping the model to be able to classify sentences correctly. And we were applied two additional methodologies when prompting, layered prompting approach and combined approach. The combined approach where in layered prompting approach, model was stressed the second and the third time to convert or deny previous output. And in a combined approach, two different models were combined with conditions or and for the final event classification. And pros and cons of this model, the main advantage is of this approach is that practically no labeled data needed, and could be so it could be easily extended for other event types. But also, this model is sensitive to prompt design, and also access to large language models can be costly, especially to the newest and most advanced ones. What's more, those models often experience downtimes or slow performance. And we got results. Both large language models performed quite similar, although Gemini Pro model a bit improved when applied layered prompting approach. However, it showed lower performance in comparison to OpenAI GPT. And the best performance was achieved combined both model with an F1 score of 61.4%. And for direct comparison, as you can see by the results from both models on the same goal corpus and of the same event types, so we can compare them directly. And as we see from the results tables, few shot approach outperforms synthetic data approach on all metrics. The biggest gap could be seen in precision and F1 score. So for the first discussion, the main point that synthetic data-based trained model underperformed to few shot large language models. Maybe that synthetic data lacked much of real-world diversity, which could be improved with more sophisticated prompting techniques, especially for Lithuanian language, which is morphologically complex language, which possibly require more diverse examples. But on the other hand, both approaches performed quite satisfactory and showed that they could be used for under-resourced languages like Lithuanian. And so to conclude the research, I can say that few-shot approach outperformed initial synthetic data trained models. But despite that, static data approach still works and could help save API cost and ensure availability. And for the future work, I plan to expand with different event types, refine synthetic data generation prompts, and investigate these approaches for other languages. Thank you.